The commutative property of addition and multiplication is a property that only applies to addition and multiplication. Just like the associative property, it will not work with subtraction and division. The commutative property is all about movement or location. For example, we have some cars over here off to the left. They are commuting from home to work or from work to home. To commute means to go from one place to another. When we talk about the commutative property of addition and multiplication, we're talking about the fact that it does not matter how you order these individual numbers in your addition, that you will still get the same answer. For example, 1 plus 2 is 3, plus 3 is equal to 6. Now if I change these numbers around, will I still get an answer of 6? Well, if I shift them all to the left and bring the 1 all the way to the end, I get 2 plus 3 is 5, plus 1 is still equal to 6. So regardless of how I arrange the numbers, I get the same value. Let's try this with another problem. 7 plus 2 plus 1. What is that equal to? Well, 7 plus 2 is 9, plus 1 is equal to 10. If we put this same set of numbers on the other side of the equal sign, and we bring them over here, and now we can change the order of these numbers, and we're going to find out whether or not it's going to change the value. So let's just swap out 7 and 2. Okay, we'll change out 7 and 2. Does that change our value? Well, 2 plus 7 is 9, plus 1 is equal to still 10. Well, what if we changed out the 7 and the 1? Does that make a difference? We'll take the 7 over here, we'll put the 1 in the middle. Does this change anything? 2 plus 1 is 3, plus 7 is still 10. The commutative property, again, says that it does not matter what order you put the numbers in. If it's addition or multiplication, you will get the same answer. So which of these are examples of the commutative property? 3 plus 4 plus 5 is equal to 4 plus 3 plus 5. I have changed the ordering of the numbers. I've changed the position. I've moved them or changed their location, but I haven't changed anything else. So this is an example of the commutative property. What about this one? 5 plus 6 plus 7 is equal to 5 plus 6 plus 7. In this case, we've got grouping involved, and the numbers are in the same order. Grouping means the associative property, not the commutative property. And since these are all in the same order, this is not an example of the commutative property. Over here, we have 1 times 2 times 3 is equal to 2 times 3 times 1. And remember, the commutative property does apply to multiplication. Have we changed anything other than the order? No, we haven't. We've simply changed the order. We've changed the location of some of the numbers. This is an example of the commutative property. All we've done is commuted the 1 to the end, commuted the 3 to the middle, and the 2 is commuted to the front. Here's one. This one only has 2 numbers in it. 3 plus 5 is equal to 5 plus 3. What has changed? Well, there's no grouping. All that has changed is the order of the numbers. It does not have to be 3 numbers for the commutative property to work. It can be just 2, or it could be 4. We can have 2 plus 1 plus 4 plus 3. And if we change those around, 3 plus 1 plus 4 plus 2, we still get the same answer. That is the commutative property.